Hi all. In this video, we are going to present a paper, ImageNet classifications using deep convolutional neural network. This is one of the famous paper, and which introduced a famous neural network architecture called AlexNet. And this paper begins with challenging in image classification problem, which has 15 million labeled high resolution images with 20,000 categories, for which we need a very large, powerful models. At the same time, we have to avoid overfitting. So they adapted a convolutional neural network. Obviously, it has fewer connections and fewer parameters, and it is easy to train at those times in a very limited computational power. So again, they say the contribution of paper is again we know from the history that they introduced a very famous neural architecture, which the history first time they could able to train a deep learning architecture for image classification, like a huge data set like ImageNet. So this data set is something extracted from the original ImageNet, and that is called as ILS VRC, which from 22,000 categories they took only 1,000 categories, and for each category they took 1,000 images, so almost like 1.2 million training images, 50,000 validation images, and 150,000 testing images. The architecture is something very simplistic compared to the present scenario. It has only 8 layers, 5 convolutional and 3 fully connected, and this is and the nonlinearity is not a tan hyperbolic or sigma. It's simply a ReLU connections which avoid gradient saturations. And they also took a reasonable effort to be training on multiple GPUs. And they almost a ReLU does not require for normalization for the input, but however they adapted specialized normalization techniques to improve the training. And they also do adapted max pooling at layer 1, 2, and 5. So the overall architecture is something like this. They have 5 convolutional layers and 3 fully connected layer, and the last layer is connected to 1,000-way softmax, producing 1,000 class labels. So they train this model, minimizing or maximizing the multinormal logistic regression objective. And these are some of the setup for this normalization layers is for first and second, and max pooling is set up for the first and second and the fifth layer. So ReLU connections has been done for both fully connected and the conventional layer. And the first is about this setup with 96 kernels and straight off 4 pixels. And this is the overall architecture: the first layer, second layer, third layer, 5 layers, and fully connected 3 layers. And these are some of the setup for that. And they for avoiding overfitting during those times, still 60 million parameters are huge enough, and they wanted to avoid overfitting, and they took two standardized techniques. One is data augmentations, producing an redundant additional data by two distinct forms. One is like data augmentations using generating images using translation and horizontal reflections, and another thing is generating images using altering the interface of RGB channels in the training images. And they also adapted like Adabus Arena for us, putting out many classifiers and making an overall average. But in this aspect, they could not able to do that. So what they did is they try to go for a technical dropout, which has a random connections during the forward operations with the probability of 5. So during those testing times, those each output will be multiplied by, which is implicitly meaning that taking a geometric meaning of the predictive distributions produced by exponential many dropout networks. So in that aspect, they try to avoid overfitting, and they train using standardized first order gradient descent method with the stochastic batch size, and also a weight decay and momentum of zero point 0.9. So these are the equations involved in training those updates of the parameters. So these are the weight parameters, and this is the intermediate which is computed through the momentum and the weight decay operations. So these are the things about this famous AlexNet, and hopefully we'll see some other video related to RCNN in the next video. Thank you.